All right, and then this last lesson, titrations, we're actually going to do all in one video. So I'm imagining lesson 3 probably took us more than one day, and then we're just finishing off this lesson 4 of titrations. So first things first, what is a titration? Well, the definition of a titration is it's a lab process where a measured amount of standard solution, aka of known concentration, is added to a sample solution with unknown concentration to determine the concentration of a specific ion in the sample. So the purpose of a titration is to calculate the unknown concentration of ions in a solution. We are going to be doing this in our lab. So in our lab, we are going to perform a precipitation titration. So some key terms to know going into a titration is the words standard solution and sample solution. So standard solution is a solution of known concentration used in the titration. This is the thing that we will put in the burette, which I'll describe what that is in a bit. And then the sample solution is the solution of unknown concentration, which is going to be determined via the titration. And this is the thing that's in your flask. Okay. Then an indicator is a substance that's used that changes color or signals when a titration is complete. And we're going to be looking for a titration equivalence point or end point, where the equivalence point, which is also called the stoichiometry point, is the point at which the exact amount of standard solution has been added to react completely with the sample solution. And this will be shown with the indicator. So there's going to be a color change that indicates you're at your stoichiometric point. And the mole ratio of reactants will match the balanced chemical equation, which that'll make sense when we do some calculations. But what we're going to be looking for is the end point. The end point is the point at which the indicator is going to change color, signaling that the reaction is complete. So what is a titration apparatus? Well, it combines a burette, which you can spell B-U-R-E-T-T-E or B-U-R-T-E-T. I don't know what the difference is, but it's going to be filled with your standard solution. And it measures the volume of standard solution added very accurately. These burettes look massive, but they don't actually hold that much liquid. There's just a lot of precision in the data. You want to make sure you're always reading from the bottom of the meniscus, as you would with any liquid. And then the key thing with a burette is that you're measuring final versus initial reading. So what you're going to be looking at is you're going to have an initial amount of liquid, and then you're going to let some into your flask. And so the volume used will be the change between the final and the initial reading. An indicator, so an example of an indicator, so something that signals when a reaction is complete, is something like potassium chromate or sodium chromate. This is for chloride titrations, which is what we're going to be doing in our lab. And how an indicator works is that we are going to be looking for the formation of silver chloride. So silver chloride is a white precipitate. Our indicator that we're going to use is going to be a chromate, which is either going to come in the form of potassium chromate or sodium chromate. Don't know. But chromate also precipitates with silver, but it forms silver chromate, which is a brick red precipitate. So what's going to happen in our lab is that silver is going to react with the chlorine first because there's going to be such a large amount of chloride available. So you're going to be well over that KSP, right? Then when all the chloride is used up, the silver will start reacting with the chromate to form this red silver chromate. So the first persistent red drop will show that we are at our equivalence point or our stoichiometric endpoint. So again, silver chloride forms a white precipitate. This is silver chloride, whereas silver chromate is brick red. So this is what our lab's going to actually look like. So you're going to have this solution containing, what's it going to contain? It's going to contain, I'm having a brain fart, give me a sec. That's why I was having a brain fart. It's just going to contain chloride ions. So you're not actually going to know what this solution is, because otherwise it wouldn't be unknown. So you're going to have this thing that has chloride ions in it, and you're going to put in your indicator. Now it's going to have this sort of yellow color, okay? And then as you add the silver nitrate, the silver is going to precipitate with the chloride to form this white precipitant. You can kind of see the white on the top, but it's really just going to turn creamy yellow because you've got this, yellow sample solution that is getting titrated with the silver nitrate, and you get white kind of combines with the yellow. So you get this sort of creamy color. But as soon as you get a persistent red, so you'll get to a place where you're going to start precipitating the chromate ions as red, and you'll get this like flash of red, but when you stir it around a little bit, the red will disappear. What your endpoint will be is when that red doesn't disappear. So it'll kind of take on this tinge. Now, I'd almost say that this is almost a little bit too titrated. It's almost too red, but it's kind of like it'll reach a camel brown, right? So whatever you can picture yellow mixed with red, that would be persistent. So whatever color that would make. So this is what we're going to be doing in our lab. And then our goal is going to be to determine the molar concentration of chloride ions in my unknown sample solution, which I just know contains a certain amount of chloride in it. The way that you're going to do this is we're going to record the volume of silver nitrate added to reach the equivalent point. So how much silver nitrate did we have to add until we reached that point where we just started precipitating the chromate? From that, you're going to be able to calculate the moles of silver that you added. So the moles of silver is going to equal the molarity of your standard solution, so whatever's in the burette, times the volume that you titrated. So that's going to tell you the moles of silver that you added. Then you're going to use the balanced equation to find the moles of chloride. So we know that silver chloride dissociates into silver and chloride in a 1-to-1 ratio. So the moles of silver will equal the moles of chloride. So check the coefficients, but they're equal here, but not always. And then you can determine the chloride ion concentration. Can you say, okay, well, if I knew the moles of silver, I know the moles of chloride, which you can then divide by the volume of your your sample solution. So then you can find the concentration of the chloride ions in that sample solution. So those are your 4 steps, and we're just going to practice this a few times. So here's an example. To find the chloride concentration in a seawater sample, a 25 milliliter sample was titrated with 0.5 molar silver nitrate using sodium chromate as an indicator. At the equivalence point, we used 26.8 milliliters of silver nitrate. What was the concentration of chloride in the seawater? So the first thing that we want to do is record the volume of silver nitrate added to reach the equivalence point. Well, they're telling us that 26.8 milliliters, which is equal to 0.0268 liters of the standard solution, was added. So the next thing we're going to do is we're going to find the moles of silver. So to find the moles of silver, it's going to be the molarity times the volume, and again, it's in a 1-to-1 ratio. So we're going to use the 0.500 molar standard solution times the 0.0268 volume that we used. So let me grab my calculator. 0.5 times 0.0268 is 0.0134 moles. So my standard solution contained 0.013 moles of silver. Because silver chloride is in a 1-to-1 ratio, I know that the moles of chloride would also be 0.0134. So if I wanted to find the concentration of my sample solution, I could say that the concentration of chloride is going to equal the moles of chloride divided by the volume of my sample solution. So my moles is 0.0134 divided by my 25 milliliter sample, so 0.025 liters. And I'm going to do 0.0134 divided by 0.025, which gives me 0.536 as my concentration of my chloride ions in my unknown sample. Right? Step by step, we did it. Okay, let's go on to the next one. Let's make it a little bit more like a lab. So for this next one, we have a 25 milliliter sample solution containing an unknown concentration of chloride ions titrated with a 0.1 molar silver nitrate. So same. We, instead of doing one sample, we did 4 trials. We found that in each of the trials, we added a different volume of my standard solution, but they're not too far off. So what I'm going to do first is I'm going to find my average volume of my standard solution. So this is the average volume of my standard solution. So I have 4 trials. So 18.25 plus 17.86 plus 17.91 plus 17.8 divided by my 4 samples. So I've got 18.25 plus 17.86 plus 17.91 plus 17.88 equals, divided by 4 equals, I get 17.975 milliliters. So I'm going to use 0.017975 liters, but I'm actually only keeping 4 sig figs, right, in my sig figs. So the next thing I'm going to do is find the moles of silver. The moles of silver is going to equal the molarity of my standard solution times the volume of my standard that I used. So it's going to be the 0.1 times the volume, which is going to give me 0.0017975. And then the moles of chloride is going to be a 1-to-1 ratio, so it's going to be the exact same. So that I can find the concentration of chloride by taking the moles of chloride and dividing it by the volume of my sample solution. So I'm going to take that answer, 0.0017975, and I'm going to divide it by my sample solution, which was 25 mils. So it's going to be 0.025. How many sig figs? 4. Then I'm going to divide that out. And I get 0.0719. Now I need 4 sig figs, so I'm going to put a 0 on the end of that. So my concentration of my chloride ions is 0.07190. I should add a, oh no, sorry, it can only be 3 sig figs. I was right. Right, I was thinking about my volume, which was 4, but then my concentration, oh, actually, I think I might be right. No, because I had to go through moles. So when I did this was 3 sig figs, 3 sig figs. So then I was doing 3 sig figs divided by 4 sig figs, which would be 3 sig figs. And then I forgot this was actually an official answer. So I should have answered 0.01798 liters as my final answer for A. Right? So anytime you give a final answer, you want to round it for sig figs. But if you're going to use it again, you want to use unrounded. Awesome. Okay, hopefully that felt good and you're feeling prepared for Lab 5.